Hi, Assalamualaikum and a very good morning. Welcome back to reinforcement exercise 4.4 intermolecular forces part 2. If you haven't watched part 1, please watch part 1 first and click here. If you have, let's proceed with the video. Okay, for today, we'll be continuing doing another 4 exercises. So let's get started. So exercise 5, explain why the boiling point of the chlorine gas is higher than the bromine and why the vapor pressure of acetone is higher than the ethanol at room temperature. Okay, so I think this one is quite obvious to you, and you might be dealing with a problem when answering this part. Okay, so for this section, you need to know the structure of acetone and ethanol first. So for acetone, you will get the structure to be something like this, where the oxygen is has double bond with the carbon. Meanwhile, for ethanol, they have a hydroxyl group. So as what you can see here, it can form hydrogen bond. But here, you cannot form hydrogen bond. It just have a dipole-dipole forces. So for the first section, you can say that the boiling point of the bromine is higher than chlorine because the size of bromine is much larger than chlorine. So bromine is more polarizable and has higher polarizability, and hence electron can be distorted more easily and hence have a stronger intermolecular forces. Hence, more energy is needed in order to break the bond, which results to a higher boiling point. For the second section, you can say that the hydrogen bonding is formed for the ethanol molecules. However, in acetone, it only has the van der Waals forces, which is the dipole-dipole forces. So if you were to compare the strength, the hydrogen bonding is much stronger bond than the van der Waals forces. So when in the ethanol molecule are held more strongly towards each other. So when they have a stronger force of attraction, it is less able to vaporize because it is bonds more strongly. So it is very hard for the ethanol molecule to be evaporated from the surface at room temperature, and that's why ethanol has less vapor pressure. Next, by using a suitable example, explain hydrogen bonding and its effect on two physical properties of a substance. Okay, I think the answer is quite obvious to you. It's also given in the lecture note. So first, you need to draw the hydrogen bonding. So as what you can see here, one molecule of water can form 4 hydrogen bonding with 4 other molecules. So here is a covalent bond. The OH single bond is a covalent bond. Meanwhile, the dashes bond is the hydrogen bonding. Okay. And then you can explain a bit about hydrogen bonding, where hydrogen bonding is the force of attraction between the positively charged hydrogen atom with one molecule of the electronegative atom, such as fluorine, oxygen, and nitrogen. Which means that the hydrogen must be attached with either oxygen or fluorine or nitrogen. So when the hydrogen is either attached with these 3 atoms, then only a hydrogen bond can be formed when it is interacting with another molecule, because intermolecular forces is between one molecule to another molecule. And then the effects of hydrogen bonding will causes the increase of boiling point and melting point, because hydrogen bond, as you have known, is a very strong bond. And in ice, the water molecule is being arranged tetrahedrally, where it will form an open structure. So when there is an open structure, the volume will get higher, and then if you were to relate that with density, the ice will be less dense than water, and that's why ice float on the surface of the liquid water. As you've seen, for example, if you buy drinks in the cafe, so you will see that the ice will float and the liquid will goes down. Alright? For exercise number 7, so explain why fluoromethane has a higher boiling point than ethane. So as what you can see, the boiling point obviously higher, and fluoromethane has this formula, meanwhile ethane has this kind of formula. So if you were to count the molecular mass, this one and this one will be the same, but the molecular mass of fluorine will be 19 gram per mole. Meanwhile for CH3 gonna be 12 plus 3. so it's going to be 15. So it's not much different between their masses. So there must be something that causes fluoromethane to have a higher boiling point. So first, both molecule of ethane and fluoromethane having identical number of electrons and almost similar molecular mass. But fluoromethane has a higher boiling point than ethane because it is a polar molecule. So it has a stronger dipolar forces because you know fluorine is a very electronegative atom. For ethane, ethane only consists of carbon and hydrogen atoms. So it is a non-polar molecule and only has a weak London dispersion forces. So more energy is required to overcome the stronger dipolar forces in fluoromethane than weak London dispersion forces in ethane. Okay, I think that's conclude the exercise. Now, last but not least, we will cover the last exercise in which why between butane and 2-methylpropane, which one has the higher boiling point? Provide your answer. Okay, as what you can see here, the formula are basically the same. 1 carbon, 3 hydrogen, 1 carbon, 2 hydrogen, 1 carbon, 2 hydrogen, and this one only has one extra hydrogen if you were to count the molecular formula. But then this is not the mass is not a major factor. What basically happened is the arrangement or the molecular shapes of the compound. So as what you can say, butane has a higher boiling point because it is a linear alkane with a larger surface area of contact and thus has more area to form a London dispersion forces and hence created a stronger dispersion forces because it can form more. And then for the 2-methylpropane is a branch alkane. It is more compact, spherical and only has a smaller area of contact in order to form dispersion forces. So we can say that the dispersion forces in the 2-methylpropane is a weaker forces. So this one will be here and this one going to be along and linear. Okay, I think that's all for the exercise. Thank you for watching and have a nice day. Bye.